All right, so let's talk about the benefits of TDD. And to me, there are two clear benefits of TDD that I've seen in my experience. One is regression benefit, and the other one is the design benefit. The regression benefit, of course, is to make sure the code that worked before is continuing to work. That's a verification we talked about. And we can get this kind of feedback verification that the code actually continues to work. And one of the things I realize is, if you don't have any automation testing, you don't get the benefit of regression. And the more you start writing, the more benefit you get. And it seems to be kind of a little bit linear, if you want to talk about it that way. It seems to be giving the benefit. More tests you write, the more benefits you get. It doesn't mean that you can keep writing more tests, but maybe it tapers off a little bit on the other side. But on the other hand, the design benefit is where it can help you to write a better quality design, but there are a few things about this. The first thing is, I don't actually believe writing automation testing automatically gives you better design. I wish that was true, but I don't think it actually is. And the reason I say that is, automation testing is, if we think about it as a mechanical process, where we simply blindly start writing automation testing, we don't get any design benefit at all. In fact, I'll give you an example. I had a client who wanted to do a course on TDD, and I helped them with TDD and offered the TDD course. And about a year went by, and they emailed me and said, we want an advanced TDD course. I said, oh my God, why would you need an advanced TDD course? And they said, because it doesn't work for us. I said, okay, if it doesn't work for you, why would you want an advanced course in this case? And I said, you know what, sure, why not? I'll come and do an advanced TDD course, but what I want you to do is, before I come to do the course, I want you to send me your code, sample of your code, and sample of your test. That way I will read through your test, and when I come and do the advanced TDD course, I can critique it and tell you how you can do better. And they said, oh, we love it. This is a great idea. We will do this for you. So this was about scheduled for 3 months in advance, and I'm waiting for the calendar to move. And a week before the TDD course, they finally said, all right, here's the code for you to review before the TDD course, advanced TDD course. And they sent me the test, and I looked at it and I realized why it doesn't work for them. Because I'm not kidding, one unit test, just one unit test was 750 lines long. And I looked at this and said, my goodness, why would this one unit test be 750 lines long? It was not a unit test at all. And they said, it's a unit test. I'm like, why would you say it's a unit test? And they said, because we run it in JUnit, right? So no, it's not a unit test, it's a monster. And if you never think of what it's doing, and you simply write it and say you have a unit test, how could you get a design benefit out of this? So it's very important for us to ask ourselves, is this test really doing anything for us? So in other words, here is one thing I really like about test. The way you write a test is this. If I want to write a test for a piece of code, I would first write one test. I'm telling you how many times I see this. When I sit down work with programmers, you say you want to do TDD, about one test and 300 lines of code. Like, whoa, hold that tiger. What did you just do? Well, you got a test, right? I got to write code for it. No, you write one test, just one test. And the minute you write the test is actually talking to you, but you won't hear it if you don't listen to it. So you write this one test and you pause and you look at this test and say, what are you saying? And the test is saying, for a user, a programmer to use this function, they got to set 7 things up. And then you ask yourselves, is that actually the right thing to do? Is this lightweight? Is this the best way to access this? And then you're like, no, I'm going to rework this test, and I'm going to reduce things and make it easier to go through. And you haven't even written a piece of code, and you're sitting there and changing the test a few times. Oh, what is the method name? How many of you can give a beautiful method name? Nobody, right? You guys are honest after the break. I like you guys, right? Absolutely nobody. In fact, this is one thing about programmers. We can easily name our children, but very difficult to name our variables or functions, right? I mean, it was easy to name my children. My wife comes to me and says, hey, children's name, here's the names. She's like, really? Absolutely. How do you know? That's it, we are done. Next question. And I would sit there 30 minutes. What variable name should I give for this, right? It is hard to give names for variables. Easy to give names for children, right? And the point is, it's an abstraction we have to think through, and that's a lot difficult. So when you write your first test, you look at the name. Should the method name be this? Should I restructure the method name? Should I change it? Make it an active voice? What parameter should I send? How many parameters should I send? What should be the name of the arguments, the name of the parameters? A lot of these things you think through, and getting that right takes a little bit of time. So in other words, I want the very first few tests to form the skin of the code I'm writing. And the later few tests I write begins to form the guts of the code I'm writing. And you want to give this opportunity. So the very first test, second test, third test, fourth test, what are these tests doing? Slowly shaping the skin. Say, oh, here's the name, here are the parameters, here's the name I want to provide. And then you start slowly providing the implementation details within the code. And about the fifth or the sixth test, including negative tests, you got the code really doing what it's supposed to do. If we're not taking the time to grow the code using these tests, and I see this oftentimes, somebody writes one test and 30 lines of code, and the next test and another 30 lines of code. That's not test-driven development at all. It is just mechanically saying, you want test, I'm writing test for you, right? And it's a lip service to say, oh, we got test, and that doesn't really serve any purpose. So you want the test to grow the interface and take shape of the code, and then the later test should form the guts of it. If we are really conscious in writing the test and writing the code, then and only then the test begins to influence the design. If we're in a rush to just throw some tests together and move on, you might get regression benefit out of it, but you rarely get the design benefit out of it. That's one thing. The second thing about this is, when you look at the curve, you don't have any test, you don't have any design benefit from the test, and then as you're writing the test, you're getting the design benefit, but I believe there's a time when it begins to come down, and you don't need the test anymore to create a better design. And I think most of us get to that point maybe in about 2 to 3 years of active TDD, because your mind has changed completely over time, and you start thinking more modular, and you think through how to really decouple, and the test has become a nice training wheel, and you don't need this training wheel anymore. At that point you may say, do I still need to do TDD? And I don't do TDD today for the design benefit. I've been doing TDD for quite a long time, and my mind has been rewired to think more modular. But I do TDD today for the regression benefit and less of the design benefit. However, when I work with developers, not everyone is in the same level. I might have developers on my team who can also get the design benefit today, even though I may not get that today as I did a few years ago, and it's still worth for them to get that benefit as we develop it. So I still feel the reason to really continue to do this, and I strive to do these tests for that reason. But unfortunately though, there are a few challenges when it comes to writing these tests and writing the code and evolving the design with it. And one of the challenges is, this is one of the problems we have to unfortunately deal with. And the problem is, the worst enemy that we have is ourselves. As they say, what really makes it hard for us to get better is how good we are already. And this sometimes begins to hurt us, make things really hard for us. So in fact, I would argue the much better you are as a developer, the harder it is for you to do this. And the reason I say this is because, what does TDD really require? I'm going to say it requires a part of learning and a good part of unlearning. And this unlearning is the most difficult for us to do. It's easy for us to learn. We have been learning really, really well almost all through our lives. But the unlearning part is the most difficult for us, because unlearning requires a little bit more conscience than learning. Unlearning requires a change in habits, change in behavior, and we cannot do that so easily. And learning is a lot easier than unlearning, and unless we consciously work towards unlearning, it's very difficult for us to let go of the practices we already have. And so TDD requires enough of unlearning as well. And when you work with really good developers, the minute you tell them what you want to do, most of them have written code in their minds already. And I know you have done this, right? You're just entering the elevator, and as the door is about to close, one of your customers or business analysts walks in and gets into the elevator. And you're going up to the 10th floor, but the business analyst starts telling you about a feature they want to implement. And while the business analyst tells you a feature, you already coded in your mind. All you have to do is go back to your desk and key that in, and it works, right? And we get good at this over time, and we are getting better and better with experience. But that's what matters, really bothers us, because we cannot write code the same way if you want to do it test-driven development. We got to structure the code differently to be able to do this, and a lot of us are not willing to unlearn and take on a different approach to doing it. That becomes one problem. The second problem with this approach is we often say that it takes time to do it. Now, this is one of the biggest fallacies in our field, because we always say TDD takes time. So we all know the cost of doing it, but we often tend to ignore the cost of not doing it. And there's a huge cost of not doing it. And what happens when we don't do it? Well, there is a cost of not doing it, and that we pay in terms of fixing bugs and fixing bugs and fixing bugs over and over and over. And I often ask organizations, how much time do you spend in fixing bugs after you go into production? And they say a few years to few months, depending on the project. And if you're really spending few years to few months, what happens when you go put in production and people find problems in production? How much time and effort does it take to fix it? Well, there are many more people involved in this particular problem. That's more expensive. But we don't account for it so much. And as a result, we say we don't have to worry about it. This is my cost, right? That's why I was mentioning earlier in my previous presentation, this is like 1820s, because the doctor said the patient was alive when he left the building. I don't care, he was dead 2 weeks from now. It's not my problem, right? So I'm done with my coding. It worked on my machine. Too bad it doesn't work in production. That's not my problem, right? So we tend to do this quite a bit, and we have to really get mature about it. But that also brings up another problem. When you go to people and say, hey, I want you to really do TDD, and what do they say? Well, yeah, I can write code really, really fast. And the more experienced we are, the really better we are in writing code. And there are two ways to write code really fast. One way to write code really fast is to ignore any quality, right? If you don't have to worry about quality, it's very easy to write code really fast. And of course, it doesn't work, but that's okay. We are really fast in writing it. So we can write code really fast with poor quality, but TDD says, slow down, think about your quality, think about programming with intention. Is the code readable? Oh my gosh, these things are going to take time. But there's another thing that takes time also, and that is, if you have not done this before, TDD is a skill. And what happens when we are dealing with any skill? So TDD is a skill, and like every skill ever known to man, what happens when you try to acquire a skill? We suck, right? Remember the day you first wanted to ride a bicycle. Did you sit on a bicycle and go around the park and say, I'm that cool? No, you had a scratch, you had a little bump here, you had to limp for a few days and say, this bicycling is really fun, except when it doesn't work, right? We learned that for a few days. And what was the first day you started driving a car? I remember that day very well. The entire city of Houston was scared when I got into the car the first day, and they said, take a break, Venkat is beginning to drive today, right? And I drove the city mad because I wanted to drive, and it was the scariest day, right? And anytime you do something new, you are going to suck at it. But you do this for a while, and you get better, and you get better, and one day you don't even think about it. It becomes such a comfortable thing to do. And that's exactly what we do. It's just a skill. We got to take the time. But the problem with TDD is, what do we normally do? We go to a team and say, hey, have you guys done TDD? Oh, never before. How long have you been coding? For 15 years. Good news, on this project, you're going to do TDD. And I'll give you exactly the same amount of time, the same amount of budget, nothing changes except you're going to do TDD. This is completely illogical. That is called TDD. But the T there stands something for different. It's called threat-driven development. You threaten people now, and you say, you're going to have the same schedule, but we want you to release full automated testing. And that threat doesn't go very well, and that becomes what is called the threat-driven development, and nobody works well in this kind of threat situation, right? And so we don't want threat-driven development, and that is not going to help us at all, so we got to do a lot better than that. So how do you eliminate this threat? Well, the first thing is we got to accept it is a skill. And the minute we accept it's a skill, we want to take the time to develop that skill. Imagine for a minute you are, going to work every day, and you see this person walking to work while you go to work every day. And one day you bump into this person at the grocery store and say, hey you, I've seen you on my way to work every day. And the person says, oh yeah, I work in this area. Oh really? That's very close to where my office is. Oh yeah, it's really taking me an hour every morning to go to work. That's a long walk. You say, oh my gosh, you take an hour to walk to work every day. I go there every day as well. It only takes me 10 minutes. And the person says, 10 minutes? How do you go there in 10 minutes? Oh, I ride my bicycle. You should try this too. Really? It's bicycle, it only takes you 10 minutes? Oh, absolutely. And the person says, thanks for the tip, I will try it. And 2 weeks later, you see this person, and you say, hey, how did it go? And the person says, that's the stupidest idea I ever got from anybody. You say, oh my gosh, what happened? He says, you told me to take the bicycle and go, so I trusted you. I went to the store, I bought a bicycle. Look what you did to me. And I have a bandage over here and a bandage over here, a scar over here. And you're like, dude, do you know riding a bicycle? No. And it's like, oh, sorry, it's not going to take you 10 minutes to go to work. It's going to take you somebody 10 hours and hours to run behind you. And the older you are, the more you're going to suck really trying to learn to bicycle, right? We all do this. And imagine if I come to you and say, can you teach bicycling for me? You're going to be, oh, thanks, Venkat, I got something else to do, right? You're not going to be interested in doing that. Well, I remember my little son wanted to ride a bicycle. So I went with him, and I was running behind him, and immediately he said, oh, Daddy, I don't think I will ever be able to ride a bicycle. I said, oh my gosh, why you say this? He said, because look at you have to run behind me all the time. I just laughed and I let go of him. And he's just riding, still talking to me. And there's only so much this old man can run. I stopped, and he's still riding the bicycle. And he took a turn, he was like, you're not with me, and he fell off, right? That's when he realizes I'm not there with him. The point really is, we learn quickly when we're a child, but the more elder we are, oh, I'll tell you, it was horrible for me to learn to ski. And I found myself 6 feet above the ground 3 times. It was not fun. That was the first and the last day I ever tried to ski, right? And it's like, oh, I'm so brittle, I'm so tensed up. I gotta let go. I gotta unlearn so for me to learn. Well, that's the problem we all go through. So if you want to really ride a bicycle, what do you have to do? It's not going to take you 10 minutes until the day you're proficient riding a bicycle. And until the day you're proficient riding a bicycle, you got to invest some time. Maybe, start on a weekend. Find a nice friend who can help you to ride a bicycle. And then once you're a little comfortable, when the streets are empty, you go on your own to ride a bicycle. Which means we got to invest TDD time on side projects. We have to invest on personal projects. We have to invest on projects that are not critical, and while at the same time investing them on the projects we are working on, have other people on the project who are good at TDD who can help us along the way. And these things have to come in place for us to get better at it. If we don't invest into learning and unlearning, we cannot get the benefit of TDD. And in fact, most of the people fail at TDD because they give themselves this one shot at TDD, and they find that they suck doing it, and they tell, this is horrible, this will never work, we're not going to do it. That is like riding the bicycle one day and giving a bicycle for the rest of your life saying, this is not going to work. We know that's kind of stupid, but yet we do this on TDD projects because we don't realize it's a skill we have to invest in, take the time for. So, given this, how do we use TDD to evolve the design? Well, the way I find that we can use TDD to evolve the design is by focusing on some design principles and apply these design principles along the way. So to me, when I do TDD, I constantly ask the question, is this code dry? Am I violating the don't repeat yourself principle? Am I violating the open closed principle? Am I violating the least cost efficient principle? Am I honoring the single responsibility principle? Am I making the cohesion high? Am I lowering the coupling? These are the questions I constantly ask when I write test. To me, test-driven development is not a mechanical process where I write the test and I go home. Every single test I write, I stop and ask the question, what design principle am I violating at this point? What design principle am I honoring at this point? What are the consequences of this code the way it's structured? Am I really fostering a lightweight design? Am I really lowering the coupling? These are the questions that should come to our mind when we are writing the test cases. If that kind of questions are not coming in our mind when we are writing the test cases, we're not using test to drive the design of our code, that becomes extremely critical. This is also the reason why it's almost impossible to come back and write the test after writing the code. If you have written the code already, the code is not structured in the way you can write test efficiently with it. And then when you come back to write the test on it, you may get the regression benefit out of it, but it doesn't give you the benefit of asking, how should I structure the code? What should the method names be? What should be the interface be? Well, those things have been done already. It's a little too late to influence that unless you're willing to throw that away and rewrite it. But why would we want to do that? We have already written the code. And this is one of the reasons it's important to avoid the urge of writing the code before writing the test. Write the test and write the code and write the test and write the code. It's a nice rhythm you want to follow. But how do you go about writing this? Well, some other day one guy came to me and he said, here's the way I've been writing. I come to work and I write 20 tests and then I start writing code. Like timeout, don't do that. Well, another guy said, I write code on Monday and Wednesday and then on Friday I write the test. Not a good idea, right? So in other words, what you want to do is you want to follow this nice rhythm. So say that I'm walking along the beach, I don't let my right foot walk for a mile before my left foot catches up. Instead, what do? I take a very nice rhythmic step. I write a piece of test and a piece of code, a piece of test, a piece of code. So you want this nice rhythm to follow. And once you get into this nice rhythm, you're in perfect harmony right now, right? You're writing a little test and then you're writing enough code to your test is teasing out the code you need for that stage, and you're writing that code minimally, and then you write a little test and then a little code, a little test and a little code. If you write code and test like this, take a wildest guess. What is the coverage you're going to have on that code? 100%. So I don't care about coverage at this point, right? Because I never wrote a piece of code without writing a test for it. Okay, we're all human. And you're sitting there and writing code, and somebody asked you a question, or you write a little code. But in my case, I never write that code. Aliens always come and write it in the night. But when I run the test coverage, what happens? It says 97% or 96%. And there's one thing you can do beautifully so well. Go in and delete that code that doesn't have a coverage. How would it feel, right? A little apprehensive, but delete it. Then come back and write a test, and then you decide whether you should have the code or not, and you can keep it at 100%. But having said that, I want to emphasize one thing though. Don't assume that if you have 100% coverage, it is actually good. I'm going to speak through both sides of my mouth right now. I'm going to praise it and also not praise it at the same time. I'll tell you why I care about code coverage. I care about code coverage because every single time, and it's not happened to me otherwise yet, every single time, when I see there is a poor coverage, even a little bit, 1%, 2%, I always go to look at that code. And the minute I look at the code, I invariably see something that has to be done better. Either a design principle is violated, either there's a duplication of code, there's something else that's a poor quality. And immediately, I'm not talking about how to improve the code coverage at this point. I'm always saying, how can we improve that design? So anytime I see a little bit of a less than coverage, a red, I go back and inspect. And absolutely every single time I've looked at it. And almost I'm eager these days because when I go to look for it, I ask myself, is this one time I will see a code that requires no change at all and I can live with this coverage like this? And that day has not happened yet. So I look at the code, I always see a little flaw in the design or a poor quality. So I use this to be able to look into that for that reason. The second reason, having said that, I'm going to emphasize, just because you have a high coverage, it doesn't mean your code has no problems. Because there's quite possible that your test is covered through the code, but maybe there is a particular data that can come in that can blow up this code entirely, and you haven't handled this exception. The test coverage is not going to tell you this, it's going to show you 100%. So in that regard, a test coverage report to me is like the cholesterol number. So you go to the doctor says your cholesterol number is really bad. If you don't fix it, you're going to die out of heart attack. Well, boy, that's really a threat. I better take care of this. And you say, doc, what should I do? Well, exercise, eat properly, get some rest, and do a few other things, and here's some medicine, take it. So you do all that for 6 months, and you go back to the doctor looks at cholesterol number and says, I don't know what you have done, but good job. Whatever you have done, continue doing it. Your cholesterol number is really good. Immediately you extend a piece of paper and say, sign here, please. What is this for? Sign that I'm in good health. What does the doctor say? No, I'm not going to sign that you're in good health. All I can tell you is your cholesterol number is not bad, right? And so this kind of like that. If your cholesterol number is bad, you're in trouble, but you don't celebrate. You don't have to throw a party. Good cholesterol number party. Do you ever do that? Right? Invite all your friends and say, let's celebrate. For what? Because I got a really good cholesterol number. That's one way to bring it down, actually. So the point really is, you don't get bonus points for having a good cholesterol number, but you get really all these prescriptions if your cholesterol number is not really good. Coverage is exactly the same. If your coverage is poor, do something about it. If your coverage is really good, well, don't make a big deal out of it. Go back and do your work now and see what else is that need to be improved. That's the way I look at it. So when it comes to design, I look at design in two forms: a strategic design and a tactical design. So a strategic design to me is a very high level design I often create. I often do this potentially in the beginning of a sprint or a little bit before the sprint. Or I may even do this before I take on a fairly important feature I want to implement. I would come up with a strategic design. A strategic design gives me a good idea. Here's a design idea. Here's how I want to implement it. And I often do this in a very informal manner. On a recent long flight I was taking, I wanted to implement a fairly complex feature that I wanted to implement for the project. And so what did I do? And before I started on this, I grabbed a piece of paper and I spent a good 15-20 minutes ironing out a few ideas for the design and wrote a few things I want to write, a little bit idea here, a little bit idea, whatever comes to my mind, a little design diagram. I would throw things together. This gives me a direction I want to take. And the most important thing about strategic design is it is just an idea. Don't let anyone, including yourself, tell yourselves that you have to commit to that particular design idea. It is not something you have to implement. It's more of a direction you want to take to move forward rather than being a destination you have to commit to. So once you decide what kind of design you want to implement, in what direction you want to move, then the next step is to start with a tactical design moving forward from there. A tactical design can now start refining your strategic design idea, and along the way it may tell you, hey, this is a good idea, keep going, or it may tell you, take a different direction and change directions. It can help you to do that. So you start with a strategic design, and then you go through a tactical design, and often I use TDD to evolve the tactical design from that point onwards, and I structure these things moving forward. We got about 20 minutes on our hand, and what I want to do is this, if you're willing to participate in a little exercise. I want to give you a problem. It's a very simple problem, but it also is a very fascinating problem. I'm going to give you exactly 5 minutes to work on it. I want you to pair up. So make a lot of noise. We're allowed to make noise in this building, right? So make a lot of noise. Talk to the person next to you and throw your design ideas together. Don't worry about being right or wrong. Throw something together, and I'll give you exactly 5 minutes. At the end of 5 minutes, I'll take some design ideas from you, and then we'll do a little bit of TDD on it. Sounds reasonable? All right, so here's what I want to work on. It's a very simple and interesting thing to do, and what I want to do here is look for something that I like practicing as a TDD is a game of life. And a game of life, Conway's Game of Life, is a very interesting game. And if you Google for Game of Life, you will find this. And essentially the idea behind this game of life is, I'll quickly run through this. There is a grid of cells, a universe if you will, and it's a grid of cells, And in this grid of cells, you have all these little cells, and there are rules to know whether a cell is going to be alive or dead. And the rules are pretty straightforward and given here. A cell is going to be alive if it has 2 or 3 neighbors around it. If there are fewer than 2 neighbors, it dies because there's not enough social network around it. If there are more than 3, it's overpopulation, it doesn't get enough food and dies. If a cell is not alive, if there are 3 cells around it, it comes to life. Think of this very easy as you need a mom, a dad, and a midwife, right? So if there are 3 things, it comes to life, not otherwise. So a dead cell comes to life if there are 3 neighbors. A cell is alive if it has 2 or 3 neighbors. That's pretty much. So we want to build this little game. It's a 0-player game. You turn it on, give initial configuration, it keeps running. Here are some combinations to run. This is one structure. These guys are immortal. They all stay together based on the rule. All these structure is immortal. They don't change at all. Whereas this one, you can see the middle one is immortal. These guys come to life and die constantly. Likewise, you can see these things. So there is like almost infinite number of shapes you can look at that you can have this glider and stuff like that. So there are so many combinations. So what I want you to do is you're going to build a program that's going to do this for you, right? So I want you to think of a strategic design. What are your design ideas? What are your classes, for example? What are your, how do you approach this design? What are the things you would have in your design? Something very, very high level. I'm going to turn on the clock for 5 minutes now. Pair up with the person next to you. If you want to move around, feel free to move around. And throw some ideas together on a piece of paper, or write down on a computer, or write in the back of the person in front of you. Whatever you have to do. And then in 5 minutes, I'll check with you what you have, and we'll toss around some ideas to how to go about doing the tactical design on it. So the clock starts now. Yes. All right, timeout. So, all right, it takes a while. All right, so, oh, be quiet. All right, that's good, thank you. So, what are your ideas? Fire away. Do what? What now?
So suppose we have the API we need to implement, which is basically a finite number of methods like set cell and set cell and
So set cell,
set
get cell,
and next step.
and then next step. Okay, anybody else? I'm just throwing ideas together. So whatever you have in mind, fire away. What else? Don't be shy. Base class for what? Rule, okay? Okay, all right. What else can we think of?
So we will have something like this view, which will contain a matrix of cells.
Okay,
Now, so this view will have something like the capability to leave or to advance by one step, and we'll find like the logic for advancing to the next level in this advanced method. And yeah, so then the cells, we talked about making the cells in solid plus. Maybe it makes sense, maybe don't. We didn't get there. But what's obvious that the cells should have an access to the matrix to decide if they leave or not. And then we'll have something like creation of the new cell method, well, something like that.
okay, fair enough. Any other thoughts? Yep. Okay, all right. What else can we think of? Yep. This is getting violent. Okay, so we got some ideas put together. Now, there are two ways you can approach this. This is the way I normally approach things. You can approach things as saying, what's the first thing I want to focus on? Sometimes it's also easy to determine what to not focus on. And there's both ways to go. Sometimes I'm confused, so I pick what I don't want rather than what I want. That sometimes works. Sometimes you can pick on what you want rather than what you don't want. You saw quite a few things. Don't worry about whose idea it was, right? We got a few ideas here. If you want to focus on, what would you want to focus on first in this particular game? I'll throw something at you and you tell me it's a good idea or not a good idea. I want to first focus on designing a cell. Go for it, Venkat, or maybe not. What do you think? No. Right? Why don't you think I should focus on cell? It may be an internal detail. There's also another smell here. This is something I'm changing. I'm learning, I'm evolving, right? Like anybody else is. And if you ask me what's one thing I'm doing different today than I did about 10 years ago, I'm programming with a lot less state than I used to do. And I'm moving more and more towards reducing state. And I realized one day, I'm building heavyweight applications with a lot of field, lot of state, and I'm moving towards as less state as possible. And just trying to decide on a cell might actually force me more towards thinking about the state rather than behavior, and I want to focus more on behavior than a state. And it's not that I don't need it, I don't know yet. Yagni principle, we talked about this in the morning if you were in that session. So I can postpone that much more easily. Okay, I'm going to postpone cell. I can definitely come back to it if I want to. I'm thinking of creating a matrix of cells. And you're probably going to tell me, if we decide not to do a cell, why would you do a matrix of cell? So maybe that's something I need to a little bit postpone it. Well, okay, here is another thing I can do. I can think about performance right now. What do you think? No, I don't have anything to think about. I got to keep that in my mind, but of course, I can't really start with that. So what about, this is an interesting idea. Somehow you have to be able to advance to a next cell. Clearly, that's something we need to think about. We can't let go of it. Is there anything else here that we could probably focus on? One iteration, the result of what happens in the one iteration. What should we finally see? Right. Yeah. So we usually can get into an analysis paralysis doing that. But where do we start our focus on? We got the game itself, but what does that mean? The universe, which is the field. Should we start with the field then? No. So we're struggling here. What? Time. Rules. So a rule seems to be a good thing, except we're talking about a base class of rule. How does that feel? Over design, right? We don't need a base class. Remember the rule of triangulation. We can triangulate it when we need it. We don't even know what we're doing. Why do we want to create a hierarchy already? So these are some of the decisions. And don't get me wrong, I'm not suggesting any of these ideas is a wrong idea. We have to throw these ideas together because that's what we do, right? When we come up with ideas, we're going to come with so many different things. And your brain is saying, oh, and you're going through this, right? Oh, well, that's a great, no, that's not. And we do this all the time. And then whatever you identify, write them down, and you say, where do you start? Well, maybe I can start with the rule. But let me also crystallize this a little bit further. Maybe I want to think about it this way. I want to say, for each tick. Does that make sense? Right? This is your tick time period, right? For each tick, what do I want to do? I want to say, for each tick, I want to say, get the, decide if a cell lives, for each tick, for each cell, and I don't know what a cell is yet. I'm not committing to a design of a cell. But for each cell, decide if it lives or dies. Is that reasonable? Why not? It could be, but it could be lazy. You don't, so we're going into implementation here, right? It is infinite, then it's infinite. But that's our problem, how to implement it. Don't assume you cannot implement infinity. We have infinite series available to us in programming languages today, right? So all you care about is the context of what's relevant. And that's implementation detail. And if I assume that it's a finite field, then it's not an issue also. What else is missing?
Because we need to know which cells will be born.
Isn't that what decide means?
No.
So what does it mean then?
It means whether the existing cells will live or die.
Right.
But we also need to think whether there are cells that will be born.
There's no, life is born.
Okay.
Yeah.
The cell is just a state.
That's it. What else is missing?
You need smaller matrix.
Yeah, but that's a state, right? We don't care. That's an implementation detail. That's not a major idea to state, right? Little things that fall in place, right? You can't get your work done without it. Yes, that's okay, right? So major design idea. That's what you want to focus on, strategic, not tactical stuff, right? What is the major idea? For every tick, you're going to do this, right? And yes, can I live without those decisions? No, I cannot. But are they strategic? Not really. They'll fall in place, right? So, but then the question is, how do I determine life or death for every single cell? Well, I can say that part is probably where count number of live neighbors, right? You got to be able to count the number of live neighbors. How do you do it? I don't care. Somehow we're going to count the number of live neighbors. And then what am I going to do? Apply rule to decide, right? Apply rule. So apply a rule is going to say, well, you know how many cells you have, and apply the rule to decide whether a cell is going to live or die. So you can start approaching your problem as a very high level. Here is what I would probably do to solve this particular problem. If you try to make a lot of design decisions right now, you're going to get dragged in very quickly. There are times you have to ask yourselves, what design decisions do I not have to make at this level? And a lot of decisions have to be made, but not right now. You can postpone this to a later time. Well, if I do that, then the next step I would say is, well, you can either start building this, where you can go around and count the number of neighbors, live neighbors, or you can say, you know what, I don't care about counting. Somehow that gets counted, that could be given to me, and I can simply compute whether a cell is alive or not. Then you can start driving your design by writing a series of test cases on it. And if you do, you can start writing tests for just the rules itself. And you'd be surprised, you can actually write this with absolutely no state. Because all you care to know is whether a cell is alive or dead. That you can feed into this. You can feed in whether a number of cells that are available. And I'm not suggesting this is the right design or the only design, but that's a kind of decision you can make and say, I can simply make this stateless, where I can feed in the number of live neighbors and the current state and know the next state. By doing this, I postpone the decisions as to how to model the cell itself. I don't need to do that right now. Then after that, I can come back and say, hey, why not focus on counting the number of cells? Oh, of course, if I want to count the number of live neighbors, every cell can potentially have 8 neighbors. But now then comes the design decision. How are you going to keep all these live neighbors or neighbors? I can have every cell have reference to 8 other cells. And then you ask yourselves, how does that feel? Is that lightweight? Or does it feel it's heavyweight? And when you're starting to write the test for it, you pause and ask yourselves, am I doing a lot of setup before I can find out how many live neighbors I have? If you feel you're doing a lot of setup, you can ask yourselves, can I rewrite it in a way I don't have to do all that setup? Is there a different form I can maintain this so that it becomes easier? Maybe I can start with the field. Maybe there's an easier way to represent cells in a field than having to have every cell depend on its neighbors. These are the design decisions you have to make at that level. You don't have to make this decision at the higher level. But when you're beginning to write the test for this, you're going to feel the heat of this. And then based on that, you can decide whether you want to do this or not, and then you can refine it. So, but I think it's important to not have, it's a two-pronged, right? You don't want to start without a major idea. You don't want to get dragged into a lot of detail at this level. And that's something we have to develop the technique for. What kind of detail do I need to focus on now? What kind of detail should I not go into? There is no real right answer for it. It's something you have to kind of get a feel for and say, I don't need to know this now. I do have to know this now. And once you are comfortable with the enough detail at this level, then start by focusing on more detailed at every single level. I can design the rule first, then I can come back and design the code to find the number of live neighbors, and I can decide whether I want to model the cell at the time, model the field at the time, or how I want to do that, while trying to keep the state as minimum as possible. And once I do that, then I can come to the higher level and say, now how do I manage the universe? Can I do it in a single loop? Can I do it, what if it's infinite? How do I manage that? Well, I can figure that out, because that decision does not depend on how I keep the smaller piece of information, because that's about the higher level of information, right? Maybe so. Well, we'll figure out, right? But how could you prematurely say it's going to work or not without even trying it? It depends on what your problem is, right? I already defined to you what the problem is. Your question to me was, should I model a finite or infinite? I said model a finite. Then why are we arguing about it? Right? So again, it's our decision to make it work or not work. If it may not work for you, That's perfectly fine. Then go find some other solution that works for you. So the point is, decide what kind of detail makes sense to you at the level you are focusing on. You cannot solve every problem at this top level. And that's the best way to get into analysis paralysis and spend a lot of time. So make a decision at this level which you know about, then come down to the tactical level to make further decisions at that level, and then start refining it as it makes sense. If your problem changes, your design is not going to be extensible for every problem you can think of. So you need to start with and ask, what is the problem you're trying to solve? That becomes very important as well to solve it. So we're out of time. I hope you found that useful. That's all I have. Thanks.